The Anaktuvuk River fire scar started in June of 2007, and it burned for approximately 3 months. It was the largest tundra fire recorded, burning about 1,000 kilometers squared, which is approximately the size of Cape Cod. Six years after fire, there's still evidence of the fire scar. So here you can see, this is the dominant vegetation type or the dominant plant species in Arctic tussock tundra. This is called tussock cotton grass. It's not a grass, it's a sedge. It's an interesting plant because it forms these columns here, and they're just basically a dense mat of roots and litter and accumulated organic matter.
Fires are really rare in tundra. This particular area hadn't burned in more than 5,000 years. And that's kind of in contrast to the boreal forest where fires are very frequent.
Which you can see sort of here, closer to this tussock. This little thing used to be a tussock, and the fire completely destroyed it and killed it. And that's one of the measures, tussock mortality, we use to determine how severe the fire was.
And so my role in that combustion project, which is really headed up by Michelle Mack, who's a professor at the University of Florida, was to help figure out how much was there before. So you go out to this fire and you see that it's all black, and you can measure how much carbon is on the ground, but you don't know where the height of the soil organic matter was before the fire happened, right? Because you weren't out there ahead of time. So you need some kind of constant marker that will have the same relationship to the surface in the burned and in the pre-burned state. And so with my experience with plants, I recognized that the meristems of the Areophorus vaginatum, the cotton grass, which makes the tussocks, could be that kind of marker. And so Michelle and I together developed a method for estimating how much carbon would be in tundra at that elevation and latitude based on where the height of these meristems is. And then by difference, how much is there now after the fire burned away a lot of stuff.
Michelle Mack from the University of Florida and Gus Shaver from the Marine Biological Laboratory have quantified the amount of carbon lost by this fire. What they showed is that this one fire, the Anaktuvuk River fire, released about 2 teragrams of carbon across the landscape.
Michelle processed all the soil samples and realized that the tundra in the area of the Anaktuvuk River fire lost about 2.1 teragrams of carbon in that single combustion event in the summer of 2007.
Big deal. What is 2 teragrams? Well, that's 2 teragrams is 2 times 10 to the 12, so 12 zeros behind the 2. What is the context for that number? Well, that number is important because it's equivalent to the amount of carbon taken up in a given year for the entire tundra biome.
It's not like, hundreds of years of carbon in a sense, but it's a significant amount of carbon to get vaporized all at once.
The amount of carbon that was lost at the Anaktuvuk River fire was about 50 years worth of plant productivity. So that's a lot. So we want to understand, does it take 50 years to recover that carbon, or does fire induce changes in species composition in the way the ecosystem works, which will allow that carbon to return at a faster rate or a much slower rate?
There was a lot of regrowth pretty quickly. We measured the biomass and the soil carbon. The cover is pretty similar in terms of vascular plants, but the biomass is still a bit less. It's about half what it was before, so it's significantly different, but it's clearly on its way coming back.
So here we are at the unburned site. This is a large area next to the Anaktuvuk River fire scar that was untouched by the fire. So we can basically use the data that we acquire from this site as a direct comparison with our severely burned site, which we just visited. So looking at the tundra here, you could see quite a bit of differences in terms of the plant species and just the overall look and feel of the vegetation and the land surface. In comparison with the severely burned site, there's a lot more vegetation in between tussocks. The moss cover is substantial here. If you put your hand in there, it really sinks down. And that's a lot of organic matter that stays on the surface, but when a fire comes through, that's pretty much the first thing that goes is the moss layer. The other thing you'll find at the unburned site, which you'll not find at the severely burned site, is the presence of lichens. And lichens are important because they're really delicate species. They take a long time to recover after disturbance, about anywhere between 30 to 50 years. Lichens are an important food source for caribou. And caribou is a very important food source for the native people on the North Slope of Alaska.
Based on the way the vegetation looks now, even though the moss species, for instance, are still quite different, the prediction would be that it's on a trajectory back to being similar to how it was before over most of the landscape. But we think that over the longer term, how the North Slope is going to respond is going to depend on whether or not there's much more permafrost thaw as climate continues to warm, because that could be the signal that shifts this over and allows other fires, newer fires, to cause really dramatic changes.
Tundra burns. So for a very long time, scientists have thought that fires in tundra are not particularly important. They're small, they're relatively infrequent, and we can largely ignore them in future projections. But what the Anaktuvuk River fire really showed us is that fires can be an important part of the landscape.